Hello guys, welcome back to my channel Maison African Motives. Still working on our engineering science N3, so we are having the question which is actually on electricity from one of the question papers that we are given to focus on. So in this case we are given actually the first question which is on electricity. So if you're new guys to my channel, you can consider subscribing so that you become part of the family and you won't miss any of the classes that you shall be having. So we are given guys to state the Joule's law in words. Okay, so remember guys, the Joule's law is actually something that is taken from what? From the heat that you're going to actually have, which is equivalent to I squared times the resistance times the time that you're going to have, which is actually these are in proportion if you are to cross check, but they need this in words. Okay, so I have something for you guys which is can be better definition or description if you cross check in a better way. So I don't know how we are going to take this one, but that is actually how they need you to answer these questions. Okay, so on 7.1, the Joule's law is actually the heat developed when an electric current passes through a conductor is proportional to the resistance, the current, the time, and the square of what? Of current. So we are talking about the heat that is developed, which is the heat here. As you can see, we've got the square of the current, then we have got the resistance, and also the time that is which is measured in what? In joules. Okay, so that is the concept that we are talking about actually here. Okay, so I hope we understand what is happening here, guys. So that's actually the Joule's law there. Okay, so in the other part there we are given a fig 3. That's the diagram where we are given an electric circuit. So if you have to cross check, you've got R1, V1, V2, the ammeter reading, ammeter here. Then the parallel circuit here we're given as R2. So this is actually a parallel circuit. All right. Then on this part now we are given 3 cells, each with an EMF of 2 volts are connected in series with an external circuit as shown in fig 3 above. All right, so these are 3 cells actually with an EMF of what? Of 6 volts. So which means each part here is having 6 volts. What does it mean, guys? Each part here is having 3. So we've got 3, but 2. There are 2 volts, but 3 of them. So it's going to be 3 by 2 here. So you're going to have 3 by 2, which is actually 6 volts. All right, so that's the total voltage that you shall have actually, or the total EMF that you have there. All right, so let's see what we are given for the first question. So the first question in this case is to calculate the following: the total resistance of the circuit. All right, so we need the total resistance of the circuit, and that's 4 marks for that. Okay, so let's analyze the diagram that we are given. So we've got this R1 in series with this 3 ohm and the parallel circuit that we are given there. So okay, so this was 7.21. so the total resistance, as we said, we have got this R1, so it's going to be R1 plus the parallel circuit. We've got the parallel circuit here, so we have got R parallel, okay, plus the series circuit, which is a 3 ohm of the one of 3 ohms. I don't know how you're going to write it, because you just write 3, because this we are given as 2, so this we just call it R3. Okay, but we know, guys, whenever we are working with a parallel circuit, in order for you to calculate the total, we are going to use product over sum. So this one is actually product over sum, product of resistors over the sum of the resistors. Okay, so that means our RT is going to be R1, which is 0.5. so this is your R1 here, which is 0.5, plus the R parallel, which is the one we are using, product over the sum of resistors. So we've got the product here of the, if there are two resistors, guys, you just use product over sum, because that, and in our syllabus we just work with two resistors, so that's what you can actually use, okay, in a simpler way. So it's 2 by 4 over 2 plus 4 product, which means you multiply, so it's 2 by 4 over 2 plus 4, okay, plus the other 3, which is 3 ohms. All right, so you add because it's a series one. All right, so that's it, guys. Let's combine and see what we are going to have. 0.5 plus, if you simplify this parallel part, you're going to obtain 1,3333, something like that, plus 3. All right, then you add, you're going to obtain 4,833 ohms. So this is resistance. So remember, total resistance, guys, and resistance is measured in what? In ohms. So that is actually the idea there. You are working with resistance, and resistance is measured in ohms. So that's what the question was all about there. All right, so let's see the other question. The total, the reading on the ammeter. Okay, so the reading on the ammeter, this is our ammeter here. So we know that the ammeter, when it is placed like this in a series, it's actually measuring the total current of the circuit. So that is the reading on the ammeter. It is going to measure the total current of the circuit. All right, and we know that the total current of the circuit is actually equivalent, if you're working with current, the total current is actually equivalent to the total voltage over the total resistance of the circuit. Okay, so we have got the total voltage of the circuit. In this case, the voltage, we said is 6 from 3 by 2. Remember, we multiply 3 by 2 and obtain 6 volts. So that is going to be a 6 there. Okay, so you've got 6 over the total resistance, which is the one that we just calculated. Now we obtained 4,833, the total resistance of 4,833. So it depends with the way that you have rounded off. Okay, but here I'm using 3 decimal places, so we are going to obtain something like this from your calculator, 1,241 if you round properly, and this is current, which is measured actually in amps. Okay, so that's the total current, which is the ammeter reading. Ammeter, an ammeter measures current. Okay, ammeter measures current. So that's why we had to calculate current. Okay, if it is a voltmeter, we are going to measure the voltage. Okay, but ammeter, current, that's the concept there. So, and on 7.23 now, the reading on the voltmeters, which is V1 and V2. So as you can see, it's now voltage, voltmeters, that's voltage. Okay, voltmeters, V1 and what? So we place the voltmeter here. So if you are to cross-check the V1 there, that's, let's just write 7.23. All right, so you've got 7.23 like this. Okay, so V1 is actually the voltage of the parallel circuit. If you are to cross-check, because that's a voltmeter which was placed in between the parallel circuit. This is your parallel circuit, so in between here, so that's V parallel. Okay, of which we know that if it is V parallel, it's going to be the total current multiplied by the resistance of the parallel circuit. Okay, because we know that guys, in this parallel circuit, we combined the resistors together. That's the resistance of the parallel circuit. The total resistance of the parallel circuit is the one that we're talking about here. All right, so what was the total current? We obtained the total current. Remember, it was 4.833. Is it 4.1.2? So 4 point was the resistance. Okay, it's 1.241. So 1.241, that's our current, multiplied by the total resistance of the parallel circuit. So this one you calculated. If you know this, what you're doing is you remember that I calculated the R parallel here, and this was the equivalent product over the sum, and we obtained this from this product over sum. We obtained 1,333. So we are going to just multiply by 1,333. So if I multiply the two, we are going to obtain something like 1,654 volts, which is actually voltage, this one. So that's our V1. So as we are writing as V1 because that's what we are being asked to calculate, but it's actually the voltage of the parallel circuit. The voltmeter is between the parallel circuit. All right, then what about V2? Because we are given two things to work on. I'm not sure if it is going to work here. If we are going to have maybe our V2 here. Okay, let's see what we have on that V2. Okay, this is your V2 here, which is actually, we have got a resistor here. We just have a resistor, and it's a part of the, as you can see, this current that is flowing here is the same current that is going to flow here. So it's the total current of the circuit times this resistor here. Okay, so it's going to be total current of the circuit 1.241 times the resistor, which is under that voltmeter 2. There's a resistor of what? Of 3 ohms. Remember, voltage, guys, is current times resistance. So the resistor there is a resistance of 3. This is your resistor in ohms. So resistor you see with this ohm here. So it's current times the resistance in ohms. Okay. So multiplying this, you are going to obtain our V2, which is 3.7 something there, 3.723, yeah, 23 volts. So you just round off properly. So it depends with the degree of accuracy that you have used in rounding off, but using 3 decimal places, these are actually the answers that you are going to obtain. I don't know if you're using 2 decimal places, you might obtain answers which are slightly different from the ones that we are having, but they are still the same. They represent the same thing. Okay, anyways, that's it. Then the current through the 4 ohm resistor. What is going to be the current through the 4 ohm resistor? That's what we have on 7.24, the current through the 4 ohm resistor. So which one are we talking about? Okay, 4 ohm resistor. That's our 4 ohm resistor here. So it's easier, guys. Why? Because remember, we have the V parallel here. The voltage of the parallel circuit is there, and the 4 ohm is under the parallel circuit, where we know that on the parallel circuit the voltage is the same. Remember, I have always talked about this, guys, that in the parallel circuit V parallel is the same. Okay, so if V parallel is the same, it means the voltage which is your V1 is the same voltage which is under the 4 ohm resistor here. Okay, so what am I going to do to find the current in the 4 ohm resistor? So remember that current is voltage over resistance. So the voltage that you're talking about is the V parallel, which is V1, because your V parallel is this V1, which is represented by the voltmeter V1, and we obtained this V1 is 1,654. So you're going to have 1,654 over the resistor that we are talking about, which is the 4 ohm resistor. Okay, so you're going to divide by 4, just like that, guys. All right, so if we do this, guys, let's see what we are actually going. As you see, guys, that's why I don't put this. You see, there's too much light, but let's just divide 1,654 divided by 4, which is going to give us something like 0.4135 amps. So that's actually the current that you're going to obtain in the 4 ohm resistor, like that. So guys, as you can see, it's very, very important actually how you use the information and how you represent the information that should be given. So that's it, guys, from Mason African Motives, working on engineering science and 3 past exam papers. So if you are still new to the family, guys, and this information is helpful and you've been watching part of our videos, you can consider becoming part of the family by subscribing. And also don't forget, guys, don't freak out, share the videos to your friends and colleagues so that they also can benefit from this information that we are having for Mason African Motives. Till we meet again.